Hey guys, a lot of stuff going on around with the coronavirus. So this is Tesla Engineering. We're in the lab and we've been working on some stuff. We just wanted to share it with you. We're trying to make some ventilators out of some car parts so that we can help out the medical industry without taking away from their supply. So I'm going to give it over to Joe Mardall, and he's going to tell you about what we've been doing.
As Lars said, we've been working on developing our own ventilator design, specifically one that's heavily based on Tesla car parts. We want to use parts that we know really well, we know the reliability of, and we can go really fast, and they're available in volume. So here's our kind of high-level schematic design. You can see that all the red parts here are Tesla vehicle parts, so we've used a lot of those. And now I'll take you to our first round of prototype that we developed. And Guru can talk you through that on the bench here.
Hi everyone. So I'm going to walk you through the first prototype we've built. So this is the hospital grade supply of air that is going into a mixing chamber, which is a car part that we use in our vehicles. This is where the oxygen and the air mixes together, and then it passes through a valve body, which is used to create the waveforms, the pressure and the volume waveforms. Then the air coming out of this valve body goes to a bunch of sensors. So this is a flow rate sensor, this is a pressure sensor. It then goes through a filter and goes into the patient's lung. And then carbon dioxide is put into that air and then goes through the exhale pipes and goes through a set of sensors and then goes through the exhale valve, which is used to throttle the pressure of the lungs. So you always keep a positive pressure on the lung, so which helps the COVID-19 patients to breathe, keeps their lungs open. So yeah, that's the Tesla ventilator first prototype. And now I'm gonna put you over to Ben, who's gonna show you the packaged version of the same.
This system is powered by the Model 3 infotainment system. Up here at the top, we have a Model 3 center display touchscreen. This touchscreen is powered by the Model 3 infotainment computer in here, which controls Model 3 vehicle controllers. These vehicle controllers talk to these precision variable valves on this single piece manifold, which we designed to be easy to put together.
This gives us 3 different ways to control what's happening in the patient. Pressure regulated volume control, pressure control, or volume control for the most amount of flexibility for the most acute patients out there. We also put in on the bottom a backup system. So with an O2 tank, our backup battery, and the air compressor, you get 20 to 40 minutes to move that patient where you need to give them the care that they deserve. Now coming back up to the top, let's see what's happening on the UI. First of all, we've got a respiratory simulator right here. It's basically simulating what a lung does. It has various amounts of compliance and is breathing. That breath is actually being plotted out up here. We have 3 plots for pressure, flow, and volume. And you can see the line moving across as the lung is breathing. Now, if something happens to the lung and constricts it, you can see the pressure waveforms change, overlaid on the history of the previous 12 seconds. That's important so a doctor can see if they're improving or something's going wrong. There's still a lot of work to do, but we're giving it our best effort to make sure we can help some people out there.